Arthur's not here. Samvel. Armin.
I'm here.
Rafi. Vahan. Hamlet. Alexandra.
I'm here.
Asgeek. Asgeek not here. Georgie.
Uh,
Okay. Thank you, Arut. So, yes, Asgeek is not here. Valérie. Gegam. Gegam is not here. Narod.
I'm present.
Perfect. Sana. Sana is not here. Areg.
I'm here.
Amir Hossein.
I'm here.
Lana. Lana's not here. Arut, you're here. And finally, Gayan and Stepan. Okay, so so we already lost some people. Mm. Okay, guys, so the goal of the today class is like the previous one. We will talk about visualization tools. So I want you to understand some tools like Seaborn, Matplotlib, and Pandas. So by now, so we spent a lot of time to understand how data work. So how to collect data, clean data, scale data, and analyze it thanks to the statistics. And so the crucial step now is to make data speaking visually. So as we saw at the last class, so the visualization is not decoration, it's a tool to think better. So it will help human to see patterns in the datasets. So before talking about tools, we need to answer a simple question. Why do we visualize data? So we need to visualize to begin our analysis because thanks to the data visualization, we will build intuitive understanding. We will identify patterns, trends, and anomalies, and we will reduce cognitive loads when dataset grow. Because as we saw, in reality, we will work with big data sets. So we will be in a multivariate environment. So the cheat of the visualization is that, for instance, for the outliers, even without calculating the interquartile range or things with formulas, if we make some box plots, we will see directly all the outliers. About the correlations too. So in the next modules, we will see some specific method to see if some variables are correlated or not. But here with the visualization, correlations appear or not. And if we have a bad data quality, we will be able to see it thanks to visualization. So good visualization allows us to ask better questions. So in Python, we have all an ecosystem to make visualization. So the foundation is Matplotlib. So with Matplotlib, we have a lot of tools, and with Seaborn, the Seaborn library, we have more statistical things, but Seaborn is based on Matplotlib. Then we have Pandas, which is very fast to plot our data features. And then we have the Pandas profiling, which is like an automated exploration of the data. So most tools we will use in practice will rely on Matplotlib. So Matplotlib has some pros and some cons. So what is good with Matplotlib is that it allows a total control thanks to a lot of options. So we can custom the layouts, we can make advanced work, and it's one of the standards if you work in the industry domain. Some of the cons of Matplotlib are the speed, because it can be slow at sometimes, and yes, the speed is one of the principal cons. So when we have when we use Matplotlib, we can make some figures, we can plot some axes, so we can control things really in detail, and everything is customizable. So if, for example, we will read a dataset like Titanic. So first of all, we have to set the size of our figure. Then we will put a title. We will name the x-axis, the y-axis. So we can add a lot of things to show. So if we try to plot an histogram, we will see the distribution of our individuals in our populations. So with a basic histogram, we can begin our diagnostic for the data exploration. So Matplotlib will force you to think about every visual decision. So if you need to think about every visual decision, it's a strength, but also a weakness. Then with Seaborn, we can plot more statistical elements easier and in a more readable way. So Seaborn is built on Matplotlib, and it allows us to work directly with data frames. So by default, we can say that Seaborn is smarter. We can with Seaborn we can define some things like the size of our figure, the hue. So the hue is like the color the color of criteria, because for instance in Titanic, you know, if I make a plot and I want to see among all my points who are the people who survived and who are the people who didn't survive. So with Seaborn, we can define the color. So for instance, all the survived people will be in blue, and all the died people can be in red, for instance. For with Seaborn in the when we plot on histogram, we can define the density estimation, and this density estimation help us to understand the shape. So in comparison to raw histogram, it can gives us more information. So as we saw in the previous classes with the bivariate examples, we can for instance show the relationship between two variables, and the hue, so the color that we will define, as like a third dimension, because it's supplementary information. And in the bivariate example like that, it can allow us to test some hypotheses just visually. If we use like categorical variables, so variables which are not numerical, we can plot the relationship between two variables, for instance, but in another way. So for instance, if I take two variables, if I make a box plot, I will have the distribution with the quartiles, the median, the outliers. And as you know, so with the box plots, if we use a box plot with Seaborn, we will be able to see how this population is distributed in a good way, because it doesn't rely on the average, on the mean. So Seaborn will help us to think statistically before we even compute statistics. And then, so after Matplotlib and Seaborn, we have the pandas, because pandas, it's a library which can allow us to make really quick plots. But pandas is good if we don't have if we don't need a perfect chart. It's just if we have to check something really fast. So so pandas can be practical to things really fast, but it's not to be used if we have to make final reports. So for final reports, we won't use pandas, because pandas is not as trustworthy as a Matplotlib or even Seaborn. So pandas plotting is like stretching ideas on paper before producing our real final visuals. With pandas comes also pandas profiling. So pandas profiling is like if we want to generate a full exploratory data analysis report in just one line. So with pandas profiling, we can in one line make an automatic report. So it will gives us some more information like missing values, the distributions of our data in a population. It gives us correlations and also some alerts like the skewness or duplicates. But as you know, if it's so easy, it has some limits because it doesn't give us the opportunity to interpret all our dataset. It's good for the beginners, but it's not as precise as we need, and it needs some human judgment because the profiling just shows us what is there. So we still need to explain why it matters. Because when we have just raw data, we need to interpret. So about the visualization, principle, if we have too many colors, it can be a problem. If we have a truncated axis, it can lead to other problems. If we don't understand the notion of the scales, it can be also difficult to interpret. So when we make visualization, we need to be very very careful. We need to prioritize the accuracy over the aesthetics. The context matters to interpret our visualization, our visualizations, and the audience matters too. So if we have a bad visualization, it can be worse than no visualization. It can lead to bad decision.
I'm sorry, I'm here. Our lights were turned off.
Okay, Arthur. Okay. I put you present. Okay.
Okay.
Okay, so guys, before testing these different libraries, so pandas profiling, pandas, matplotlib, and Seaborn, first of all, I want you to introduce your solutions about the previous exercise. So I will put again the exercise in the chat. But before that,
You mean for previous exercise, huh?
yes, the exercise of the previous class.
Oh, okay, I did. Okay, wait.
So I will put again the okay, so good. So Ami, you try to make it after the course.
Yeah. It's about the previous class, guys.
Yes, exact.
Yeah. I think the main goal of the code, the exploratory data analysis, for example, about the determine, passenger, survive, it's something like this. And here we have the import pandas, Seaborn, and matplotlib, and the matplotlib and Seaborn. Yeah, it's for the creating the chart. The panda for the data manipulate. I mean the population, I think, yeah, something like that. Yeah. And sorry, this. Okay. So here also we have the 3D print of the head, the info, also and describe. The head will show us the first 5 rows to see what data look like, the info about the check for missing value, about the data type, and the describe. It's more about the calculate the math, for example, the max mean. It's something like this, yeah. And also here we have the select variable about the smaller data frame, include different survive, age, fair, eyeglass, something like this. And also here we have the pair plot. It means I think it's meant for the create a grade of the chart comparing, for example, for every variable. It's mean the how can I tell you? It's mean about more about the survive, you know. It's the for example our question is the survive, age, fair, and the class, you know. It's more about that. For example, the colored by who survived and show us. And after that we have the heat map, but heat map it was new for me. Yeah. The heat map also it's the relationship for understanding for me. It's relationship between the variable and the visualize. It's more about this. Yeah. Can show us. Yeah. And the multivariants for the complex plot showing, for example, here, for example, showing the, I think here, one, two, three, four dimension of data at once. It's X, Y, hue, size, we have the age, fair, survive, and yeah. And here you can see our output. Wait, yeah, yeah. The correlation of Hitman, we can see here. Here you can see also the survive versus the age, fare, and passenger class.
Okay, so can you show us just the beginning?
You mean
No, the beginning of your code.
okay, okay. This one?
Yes. Okay. Perfect. So my first question is
Little bit I know about the Hitman, not too much. Yeah.
mhm,
Hitman
okay.
and motivate visual survive, for example, the age, freight, passenger. For coding, little bit about that. But basically I know. For example, the first of the code, the print, the data tightening, about the payflow. This one is easy, not problem.
So my first question is why these variables are relevant for you? Why did you choose survived, age, fair, P class? Why? What is the advantage to use these variables?
For example, you can, yeah. For example, if the think that it's for example the packets or fair. I think it's about the I think it's about the for example represent with for example the social class. I don't know, determine in your for example the your I don't know, for example your location. I don't know, and the sheep. You know, I think it's correct. And if, for example, the age, it's about the physical ability of, for example, I don't know, children, men, women. Yeah. For example, the survived. I think it's more about the, for example, this is our target. For example, we use it to see how the other three, for example, influence the outcome. You know. Yeah. Just
Exactly.
yeah.
So one advantage to choose survived is just that, like you said, so it's the target. It's in an implicit way, we all know that is the like the main because when we understand the story of Titanic, we know that survived is what we want to know, if people has survived or not. So yes, we want to see how the other variables influence the survival chance, if we can say like that. So age is a numerical variable, and the advantages are that age is really it's interpretable, but really easily, and so it will. And as we saw that it has a good variability, a big variability, so it will allow us to show the interaction with other variable like class or survival. With the fair, we know that fair includes some outliers, so it will be useful to see the effects of the outliers on the visualization. And also P class, it's P class, it's
It's
like
yeah, it's about the social class. It's about your location and, for example, the sheep. You know, for example, you are the close seat here. For example, you know, it's yeah, it's more about the location. I know this one.
yes, it's about yes location, and also it allows us to it will allow us to see the interaction on the fair on the class, because it's linked also.
Mhm.
So yes, it's a good choice of variables. So after that, mm, mm, mm. Yes, after that yes, can you show the beginning again?
Code.
Yes, okay. Yes. What you could do before showing your pair plots, heat map, etc., you could drop the null values just before, because in the pair plots and in the correlation map, we don't want to have null values.
For example, can you explain, for example, what should we do here?
Yes. So what you could do is that you, for instance, yes, when you describe with Matplotlib, for instance, when you describe the population, the dataset, we have a lot of null values, empty values. in for instance, which one?
For example, the correlation heat map and multivariate, I know just little bit, yeah. And I not too much. I don't know how to. Yeah, I just wrote something. Yeah, I don't
What
have
I mean,
any idea for that.
what I mean is that when, like we saw in the previous modules, so when you have your dataset, so here your reduced dataset is the survived variable with the age, the fair, p class. But if you look at your entire dataset, all the rows, you have null values. For instance, maybe for some people, the age is not completed. The fair is not completed. The p class is not. So what you
example,
could.
For example, it's my question. For example, we have the positive, the number 1, 2, 3. I don't know, positive.
Mhm.
For example, in the perfect positive correlation, my question, if, for example, if 1, 2, 3, the goes up, the other goes up, huh?
Can you repeat again? So you
I
told
mean,
me so.
yeah, I wanna say something example and check it, it's correct or no. For example, we have the minus number, for example, minus 1, 0, 1. It's minus 1, 0, 1. Okay. For example, for positive number, if the, for example, 1, 2, I don't know, positive number goes up, the other goes up or no? For example, we have the two variable, the value range from the, for example, minus 1 to positive, the plus 1, 1. Minus 1 to 1. For the 1, the perfect positive correlation, if 1 goes up, the other goes up or no?
If the correlation is 1,
Yeah, the value range from minus 1 to plus 1. Is it
So-
goes, if 1 goes up, the other goes up.
yes, it's if we have a positive linear correlation, like for instance 1. So yes, it means that when a variable goes up, the other two goes up. But if
So-
we have a negative value, it means that we have a negative linear correlation. So it means that
goes down.
yes, one variable goes up, the other goes down.
So what happened for 0?
For 0,
Yeah. But 0 is not minus, it's not, it's the middle. What happened for 0? Yeah.
yes, if you have 0, yes, it means that yes, if we are in a linear correlation, so it means that one yes, when one goes up, the other doesn't change.
Doesn't change, it's not relationship.
Yes, because when we are in a linear correlation context, it's like in mathematics the directive coefficient. When you have a linear function like ax plus b, like this.
It's not, nothing happened. It's not relationship, nothing. Yeah.
A linear correlation is like nothing function, like I put in the chat. So the A is like the linear correlation coefficient. So if you know in a function, if A is positive, so the plot will be
Goes up.
yes, a line going up. If A is negative, so it's a line going down. And if it's 0, so the plot will be a constant value. So if we check the linear correlation between two variables and the value is 0, so it means that when one variable goes up, the other one is just a constant. Can you see or not? Can you understand?
Yep. So for the what happened in the multivariate, for say example that
For the correlation?
no, the next, I mean here, this one.
Okay, yes, for the scatter plot.
For I mean the for what happened in the multivariate analysis. Yeah.
Okay. So first of all, you make yes. So you made the scatter plot. So you put yes. So in your scatter plot, so each point will be like an individual. So so yes, we will have each point located thanks the age and the fair in your example. The color will be different depending on the individual survived or not, and the point will be bigger or not. Is bigger or not depending on the P class. So in multivariate analysis, what we want to see in a scatter plot is if we can observe some clusters. So if, for instance, we have some groups which appears, we will be able to understand relationship between some variables.
Okay. So for example, for survive, it can be happen.
For survive.
Yeah. For example, in multivariate analysis, we will see the interaction between them.
Yes, for instance, yes, can you show us your scatter plots? So just down
here.
No, the scatter plot is sorry, it's a graph.
Graph, huh? Which one?
Yes, so the last one is the heat map. So yes, the scatter plot is just before. Oh no, okay, no, okay, yes. So you in your order, so you have the no. This one is the pair plot.
Yeah. This one is
After you have the heat map.
Heat map, and here.
Yes, and finally.
Yeah, finally.
Yes, so it's your final one. So here, for instance, so yes, we can see so the fair, is the fair in function of the age. For each point, we can see if it's alive people or dead people, and the size it's depending on the P class. So yes, so who can interpret this plot?
For example, for the for the multivariate, for example, it's mean, for example, you discovered that, for example, a first class passenger survived regardless of age. Okay. But for example, the third class passenger survived depending heavily on being a child. Maybe. Yeah.
Yes, it can be a conclusion when we see that. So is that yes, most of dead people were people with who were in the third class, so with a low fare,
yeah.
regardless of the age. Yes, for instance, we can conclude that. Yes.
Okay.
And just after before this, so you made a correlation map, which can just indicate us in a binary way. So are some variables are seem to be really correlated or not?
What did you say? Sorry.
Yes. So what I thought that it's so in your correlation heat map. So just before your multivariable analysis, so in the correlation heat map, we could see first of all if some variables took 2 by 2 were highly linearly correlated or not.
I don't know. I
So,
just
yes.
yeah, little bit. I know the. Yeah, I wanna explain something about what I know about it.
Yes, but just with your correlation heat map,
Yeah, I
you
wanna
could see
explain
that you could see if variables were correlated
yeah,
or
you
not.
can. I
But
think
here,
corrected. I think you know, we have for example, here we have the red. Okay, red bar color.
yes,
Yeah. For example, it means the. I don't know. Yeah, I think it's mean the close to one. No, I mean, say example. You know about the. For example.
yes. So here in red, it means with the correlation coefficient
Yeah,
equal to 1, it means
yeah,
that yes, it's highly correlated, but it's normal here, right?
yeah. I think it's a strong positive relationship. You know.
Yes, it's the maximum, but why is it 1? Because survived with survived. Obviously, um, if survived goes up, survived goes up. It's just obvious that okay, this diagonal is red because it's the comparison of each variable with itself. Age in comparison with age, fair in comparison with fair.
Maybe yeah. You say why it is one goes up. I think because we have used the Titanic data sets, but I mean this happens because variable the variable are often uh, logically the linked. You know, here is why it's work that way. You know,
No, in all your datasets, it will be
because
like that
it's
because
logic. You know, the
Mhm.
logic of the one goes up It's the positive correlation. Yeah, because of that, it goes up.
Because, for instance, if we compare age, the variable age to the variable age,
Yeah,
so
it's
we
the
compare,
same.
yes,
Yeah, it's the
so by
when
definition,
two variable have a positive correlation, they move in the same goes up. No, it's not. It's
yes,
yeah direction. Yeah,
exactly. But here, yes, it's obvious that yes, the diagonal is red.
yeah. We have also the blue color war. It's the close to, I mean, the strong negative relationship. The blue.
Um,
Yeah, you have the minus.
yes, but it's not as close to -1.
Maybe it's about the strong, not the negative relationship.
What?
I mean, the blue colors is the strong negative relationship.
Blue are
Blue, it's mean
negative correlation, yes, but
yeah,
strong blue, like yes, fair in comparison with P class. Yes, it begins to become important. Yes, P class with fair is a strong blue, so yes, it can
yeah.
show us first of all that yes, P class and fair maybe they are linked.
Also, we have the light and white. That's mean the no relation. Yeah, you can see.
Yes,
Yeah. Hmm.
yes, the correlation is really weak. Yes.
Yep.
Yes. So, did someone make something different or not? Or do someone have questions about this exercise, these plots? Because I know that Amir is not the only one who have some questions. For instance, Alexandra, did you
Yeah.
succeed this? Did you understand this exercise?
Yeah, it was pretty clear, I guess. And my code is not so different, like their theme.
Okay, okay. Did someone choose different variables? Or did you all choose P class, fair, age, and survived? So guys, if you don't have some questions, so we will go through the next exercise. So the goal is to just practice with different tools like Seaborn, Matplotlib, and Pandas. Mm, 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 mm. But thank you, Amir Hussein, for your questions and your works. So here is the assignment for the next exercise, just to play with the different libraries. Mm. So first of all, is the assignment clear or not? If it's clear, I will
Yeah.
create some rooms. So you will be able to work just in small teams of 2 today. So let's go. Yes, let's say let's